Hey there, geometry students. Wanted to push out a video helping out with geometry IXL standard S6, area and perimeter in the coordinate plane, part 2. So let's see if we can knock out some of these questions and alleviate any confusion. The first question I've got here says, what's the perimeter of triangle GHI? So I've got triangle GHI in the coordinate plane, and they want me to figure out and answer as to what the perimeter is. So let's take a look. Well, one, I think you've got something pretty easy to find, and that's the length of GI. So G, it's got an X value of 7, so that's 7 units back to the Y-axis. And then I, if you take a look here, it's at X value -4, so that's 4 units from the Y-axis. So that would be, what, 11 units. Okay, so 11 units from I to G. But now I've got to figure out what the distance from I to H is, as well as what the distance from G to H is. So it might be helpful to write down the coordinates of each point. G is located at 7 and 10, so coordinates 7, 10. I've got I, which is located at -4, 10. That's -4, 10. And I have point H, which is located at -6, -7. So -7 down here, so -6, -7. So what I'm going to have to do to get the distance between each of these, I'm going to need to use my distance formula, which if you haven't watched the previous video, S5, my distance formula is x2 minus x1 squared plus y2 minus y1 squared. So I need to find the distance, that's squared there. So I need to find the distance from H to I, or I to H, and then I also need to find the distance from G to H. So if I want to find the distance from I to H, well, the distance, or the length of that segment, is just going to be the square root of x2 minus x1. So let's do -7 minus 10, so -7 minus 10, and that's going to be squared, plus y2 minus y1. So, excuse me, I just did the x values. Let's get rid of that real quick. Let's do the x values to begin with. So that's going to be -6 minus -4. So there we go, -6 minus -4, and that's going to be squared. And then plus, now we can do the y values. So that's -7 minus 10. There we go. All right, so that's equal to the square root. -6 minus -4, well, like I said in the previous video, subtract a negative, that's basically like adding that positive value there. So -6 plus 4, that's going to be -2 squared, plus -7 minus 10, well, that's -17 squared. All right, so equals, I believe that's going to be 4 plus -17, what is that, 289? So that's going to be the square root of 293 units. We're just going to leave it like that. So square root of 293 units. And then we've got the distance from H to G. H to G, okay? So let's try that one. We've got distance from H to G. You're going to do the same thing. I'm going to show the setup, pause the video, and then you'll see the work actually worked out. So let's set it up real quick. So x2, so we're letting G be our second point here. So that's going to be 7 minus -6. That's 7 minus -6 squared plus, let's see, 10 minus -7. So 10 minus -7. There we go. All right. So I'm going to pause the video real quick, and you'll see you can go ahead and pause. All right, you can see the rest of the work there for HG. I basically added that 6 there when you're subtracting the negative, as well as subtracting the -7 here with 10. You get 13 squared plus 17 squared, added those values together. So this distance here is the square root of 458. Now, the reason that I'm not simplifying these radicals, if they were able to be simplified, is if you notice, I'm going to scroll down. I know it's going to move everything. But if you notice, they want our answer to the nearest tenth. So if I want my perimeter rounded to the nearest tenth, really all I'm going to do is in a calculator, I'm going to add 11 plus square root of 293 plus the square root of 458. And then I'm going to round that to the nearest tenth. So let's see if we can, I think what would be very helpful, I'm going to get rid of that just for a second. We got the desmos.com/scientific. Okay, that's going to help us out a lot, I think. So we've got 11 plus, and I believe we said the square root of 293 plus the square root of 458. And notice you hit enter. There's our answer right there, 49.518. Well, they said, I believe, nearest tenth, right? Nearest tenth. So we're going to round to the nearest tenth. There's an 5 here in the tenths place and a 1 in the hundredths. Okay, 5 or more raise the score, 4 or less give it a rest. Try to remember that. Because this 1 is less than 5, we're going to leave this 5 alone. So that's 49.5. 49.5, that's our perimeter rounded to the nearest tenth. Hit enter. Terrific. Fantastic. Let's try another one. This one's going to be pretty simple. This says, what's the area of this square? Hone in on those things. This is a square. They've already told us all sides are congruent. So if I can figure out the length of one side, I'm just going to square it. That gives me the area of the square. So W, let's just try to find the length of this side. W to X, well, that's 2 units to the X-axis, and then another 8 units. That's 10. This is 10 units. So the area is just going to be 10 times 10, 10 squared. So the area is going to be 100 units squared. Okay, units are important. So remember, these are not just units. These are units squared. So 100 square units. Boom, correct. Fantastic. All right, let's move on. Let's see what else we have. Graph this rectangle. Fantastic. So graph this rectangle TU VW with these vertices. Let's graph these. T is at -6, -8. -6, -8. Let's come down here. Okay, -8. U is at 10, 4. So we've got 10, 4 there. We've got V, which is at 7, 8. So here's 7 going up to 8. And then W is -9, -4. So -9's over here, -4 down there. There we go. There's our rectangle. Okay. What is the perimeter of rectangle TU VW? Then write as an integer or a decimal rounded to the nearest tenth. So I want the perimeter. Well, I know that opposite sides are congruent. So if I can just find this distance here, and then if I could just find this distance here, I can multiply each by 2 and add it all together. I'm going to show you real quick how to do this without the distance formula, and then use the distance formula if you'd like. I can just create a right triangle here in the coordinate plane. And this right triangle is, this length here is 1, 2, 3, 4. And this length here is 1, 2, 3. Well, this is just a 3, 4, 5 Pythagorean triple. This length here is 5 units. If you don't believe me, out to the side, 3 squared plus 4 squared equals, let's just call that, I don't know, c squared. Well, that's 9 plus 16 equals c squared. 25 equals c squared. Take the square root of both sides. Got to have a positive value, right? So 5. All right. You could do the same thing with this other side. I'm going to change colors here. Do my best to draw a straight line. So we're going to draw this line all the way across, all the way to 10. And then we're going to try to draw a straight vertical line here. Actually turned out pretty well. There we go. This is a right triangle. So what's the distance here? Well, it goes from 4 units and then another 8, so that's 12 units. And then the distance here is -6, that's 6 units, all the way to 10, so that's 16. I hope you see, that's another 3, 4, 5 Pythagorean triple. Divide that by 4, divide that by 4, you get 3. 3 and 4, so this has got to be 20 units. Don't believe me? Out to the side, 12 squared plus 16 squared equals, we'll call this something different. We'll just call it z squared. How about that? That's 144 plus, what's 16 squared? You guys got that one? I'll give you a second to think about it. That's 256, right? 256 equal to z squared. Add that guy together. I think you get 400 equals z squared. And then take the square root. That's 20. All right? So that's that side. Well, I want the perimeter. Well, that's 5, and this is 20. Well, this opposite side's got to be a length of 20. and this opposite side's got to be a length of 5. Add them together. 5 plus 5 is 10. 20 plus 20 is 40. 10 plus 40 is 50. So let's, I'm going to erase these for a moment. 20 plus 20, that's 40. 5 plus 5 is 10. Add all that together, 50 units. Fantastic. Good work. Now we've got, what's the perimeter of this guy? Well, you're going to need to use some distance formula. You can also make some right triangles. Do what I did in the last problem. Make a right triangle maybe here. You can make a triangle here to find these, what end up being your hypotenuses of your right triangles. And that would allow you to find the distances and then add them together to get the perimeter. Let's see if we can find another problem here. Jump into another level. Here's one. What's the perimeter of this triangle? We've got no vertical sides here. Let's see if we can knock this one out real quick. I'm going to use the right triangle method again. So I'm going to make a right triangle here, here. This is 3 units. This is 1, 2, 3, 4, 5, 6 units. So what's the length of FG? Well, that's 3 squared plus 6 squared. All right, I'm just going to call it FG squared. All right, FG squared, the length of FG. So that's 9 plus 6 squared, let's see, 36, equals FG squared. And that there is going to give you 45 equals FG squared. Take the square root of both sides. So FG is equal to square root of 45. I'm going to do the same thing with the other two. I'm going to pause the video to make sure I have enough time to finish this one. Okay, I went ahead and worked out the other two lengths. The length FE was equal to 6 squared plus 7 squared. You see that gives us a square root of 85. And the length of GE ended up being 4 squared plus 12 squared. And that's the square root of 160 is the length GE. Now we're going to write our answer, if you see down here at the very bottom, as an integer or as a decimal rounded to the nearest tenth. We need to add all these roots together. Let's just use Desmos Scientific Calculator. Let's get rid of that for a minute. So that was square root of 45. So again, that's square root 45. Let's see what else we had there. We had square root 85 and square root of 160. So square root of 45 plus the square root of 85, and not 850, 85 plus the square root of, what was that, 160? Yeah, 160. So 160 here. Let's type that in. Hit enter. So we get 28.57. Well, the 7 that's greater than 5, so we're going to round up that 5 in the tenths place to 28.6. 28.6 is our perimeter. Hit submit. Keep it up. Fantastic. So now you've got a quadrilateral. I would do the same thing. Create right triangles with these sides, or use the distance formula if you'd like. The distance formula is just a general form of the Pythagorean theorem, really. So we derive the distance formula from the Pythagorean theorem. So basically what I would say on all these problems is more than likely you're going to be using either, you pick your favorite. You're going to use the Pythagorean theorem, a squared plus b squared equals c squared, and just create right triangles with all these sides, or you can use your distance formula. So let me write that distance formula again to make sure everybody's got it. And if you notice, the distance formula is really just a generalized sort of coordinate plane form of the Pythagorean theorem. We derive the distance formula from this guy. These are interchangeable. You use them however you want to get the correct answer to have success with these types of problems. Let me know if you have any issues. Send me an email. Shoot me a message on Remind. Good luck, geometry students. I'm rooting for you. Let me know if you need any help.